Hi guys, Mr. Schwannekamp here. We are starting Unit 5 today. Today we're talking about powers, roots, and rational exponents. Um, in general, just a little bit about going back and forth. How are those things connected? How is a radical connected to an exponent? How are powers and rational exponents connected? Remember, when we say rational, just a fancy word for fraction. So we're dealing with these types of problems. So a root, a power, a root and a power put together, or just fractional exponents. That's it. Today's a pretty easy lesson. We'll get a little bit more difficult as we go along, but today shouldn't be too bad. Let's see how we do. All right, so there are some examples right here. This is what we're doing today. If you can only learn this whole lesson in 60 seconds, it is this concept right here. That if you wrote a root of something and you wanted to write it as a fractional exponent, whatever the root is would be the bottom of the exponent. Whatever the power is, that would be the top of the fraction exponent. So for example, if I did the fourth root of 14, that is the same thing as 14 to the 1/4 power. Okay, this is called a root. So it makes sense that it's on the bottom of the exponent. Like roots are on the bottom of trees, roots are on the bottom of fractional exponents. That's dumb, but true. This one, 36 to the 1/5 power, because it's fifth root. Cube root of 11, so that is 11 to the 1/3 power. It gets a little bit fancier here, but that is 16. Oh, that's a 16. I know that the root is going to be 9. The power this time, all of these were just to the first power, but this time we're to the fifth power. So all that means is we're going to put a 5 on the top of that fractional exponent. So it's 16 to the 5/9. Same thing here. I've got a base of 5. I've got a root exponent, so it's going to be a fraction. 7's on bottom. It's squared, so I'm going to put a 2 on top. 5 to the 2/7 power is the exact same thing as that right there. Last one, 8th root of 2 to the 11th power. That's the same thing as 2. This is my root, so it goes on bottom. This is my power, it goes on top. That's it. If you can handle that, you can do what we're doing today. So if we go one way, we can go back the other way. The 1/3 power, I've got a fractional exponent, so I know I'm going to have a radical involved. There's a third on the bottom, so that is the root. So it's the cube root of 6. This is going to be the 7th root of 4, because it's a fraction exponent. I know it's a radical. The 7's on bottom, so it's on the root value. 7, 4th root, because it's the 1/4 power. 12, 7th root because of that. And I'm going to take all of that and raise it to the 8th power. Kind of different here, but that is the same thing if I would have done this and put the power with the 12. It doesn't matter if it's on the inside or the outside. It's like saying 2 times 3 times 4. It's like grouping those two together first or grouping the 2 and the 3 together first. It's the same thing. They're going to get you the same answer. Same thing is true here. All right, so 10, we're rooting it. Since that's the bottom, that's going to be my root. Since that's my power, that's going to be my power. 8, cube root it. That's my power. Boom. Done. Just writing back and forth. This is something that probably scares my calculus students more than anything else. So I teach calculus as well. This is a lesson that I should teach it. This should be the first day of calculus. I should teach them this. And I think I do most of the time, but they struggle with it. Students see this 64 to the 1/3 power, and they could say, hey, that is the cube root of 64. And students start to struggle. Maybe not that one, but you'll see here in a little bit that they struggle with that. But what that means is some number, when I multiply it together 3 times, cube it, some number is going to get me 64. The cube root means I'm trying to break it down into those 3 parts. What number could I multiply together 3 times to get me 64? That is what a cube root means. So you always kind of know here, you could play around with some numbers. 2 times 2 times 2, not big enough. 3 times 3 times 3, not big enough. What about 4 times 4 times 4? 4 times 4 is 16. 16 times 4, oh yeah, that is 64. So the cube root of 64 is 4. If I wanted to check that in my calculator, I could take 4 to the 3rd power. That would get me 64. So if I took 64 to the 1/3 power, that's like cube rooting it. it gets me 4. It's sometimes annoying to find a cube root button on a calculator. On my calculator here, I can hit math and go down to number 4 there, which is going to get me cube root 64. It still gets me 4. All the different ways of doing it. All right, so 1 to the 1/3 power. That is like the cube root of 1. Or in other words, some number multiplied together 3 times is going to get me 1. What number multiplies together 3 times to get me 1? The answer is 1. 1 times 1 times 1 gets me 1. Now we're going to deal with this one. 16, the 4th root squared. I don't really need to rewrite it. I'd rather it be in this form more than anything else. But what does this mean? 4th root of 16. So what number multiplied together 1, 2, 3, 4 times is going to get me 16? That's what the 4th root means. Well, what number could multiply together 4 times to get me 16? The answer to that question is 2. So the inside of this, the 4th root of 16 is 2. I haven't done the square yet. 2 squared gets me 4. Okay, if I wanted to do that in a calculator, I could. Right? I could rewrite this as 16. 2 goes on top. It's the 4th root, so it'd go on bottom. So that's the same thing as 16 to the 1/2 power. Well, 1/2 power is the exact same thing as square root. 1/2 power is the same thing as a square root. Yeah, there's not a 2 in front there because we don't write the 2 in front. It's implied. Okay, if you see a root sign without a number, it's because it's a square root. The square root of 16 is 4. Hey, yeah, just like we thought it was going to be. So there's lots of different ways of doing these problems. We're trying to do it the same way every time for the most part. Square root of 4. So we're going to work on the root part first. The root part's always easier than the power. Square root of 4 is 2. And so then all I have to do is take 2 cubed. That's going to get me 8. And then these two problems are the ones on my calc kids struggle with. So 32 to the negative 2/5. Well, that is the same thing as the 5th root of 32 squared. But then I've got this negative sign. And if you've forgotten what that negative sign does, a negative sign in the exponent is going to give you the reciprocal. And so what that means is it's going to be 1 over that value. Okay, 1 over. When you see that negative sign, it puts it on the bottom of a fraction. Then we can just do this piece by piece here. The 5th root of 32. So what number, when you multiply it together 5 times, is going to get you 32? The answer is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 a 5th time would get me 32. So that is going to be 1 over 2 squared. What is 2 squared? It's 1/4. Last one, 4 to the negative 1/2. All right, cool. Let's rewrite that. 1 over, because it's negative. 4, the 1/2 power is the same thing as square root, because it's a root, because it's a fraction, and then it's a 2, so it's square root. What's square root of 4? It is 2. That is my answer, 1/2. Almost done. Down here on the bottom, all we're doing is evaluating with our calculator. So it's just a matter of being able to use your calculator. The 4th root of 49. You can do roots just kind of depending on what device you're using. So like if I use Desmos, I love Desmos, so I use it all the time. But the 4th root, let me see if I can even find it here. Miscellaneous, there it is. 4th root of 49. And I could do it that way and get 2.646. Let's go 3 decimals, just because 2.646 is my answer. That's fine, but that's kind of annoying to do because I had to find that 4th root button on this calculator. I have to hit math and go down to number 5. And then up there I could write 4 and then 49. But it's just because I'm good at this that I know where that is. If I'm not good at that, the best way to type this in is to rewrite this as 49 to the 1/4 power. That's easy to do. If I have my calculator and I go 49 to the, careful here, just depending on your calculator, but you would want to put that in parentheses. 1/4, boom, gets me the same answer. Notice that they're the same, 2.646. Doesn't matter how you get there. Figure out what works best for you and get that done. Okay, some of them we don't have to use our calculator, like these up here. Some of them you do. So these down here we're going to. The 5th root of negative 122. So I'm going to go negative 122 to the 1/5 power. I don't need to use parentheses just because of my calculator, but I'm not going to get into that here. Negative 2.614. This one should be easy, 215 to the 1/5. So 215 to the 1/5. I get that. If I wanted to go the root method and go the 5th root, because that's the same thing as 1/5 of 215, I should get the exact same number, 2.927. You don't need to show. I don't need to show you all of these. It's just a matter of typing in. If you can type in, you should be good to go here. 28 to the 5 halves power. 28 to the 5 halves power. Enter. Boom. 4,148.538. That's it. It's just a matter of typing in. So not a hard lesson. Again, the key to this is understanding this transformation. The 7th root of 5 squared is the same thing as 5 to the 2/7. The other thing that I would want you to pay attention to is this one, 32 to the negative 2/5. That can be scary. The negative puts it on bottom. The 5 is the root. When you evaluate this thing, do the root first. You don't want to have to square 32 because I can't square 32 in my brain. But if you do the root part first, it makes it a lot smaller. Like this, the 5th root of 32 is 2. Then you can do the power. So do the root first, then the power if you're doing it without a calculator. Hope that helps. If not, ask me some questions.